You've been working with resistors, but in AC there are two more components that push back on current, the coil and the capacitor. They don't turn energy into heat like a resistor does. Instead, they oppose the changing current in a way that depends on frequency. That frequency-dependent opposition is called reactance. Let's meet both kinds. First, the contrast. A resistor opposes current the same at any frequency. That's resistance, R, measured in ohms. A coil or a capacitor also opposes AC current, but their opposition changes with frequency. We call that reactance, and we label it X. Good news, it's measured in the same unit as resistance, ohms. There are two kinds, inductive reactance from coils and capacitive reactance from capacitors. Start with the coil. A coil fights any change in current. The faster the current changes, the harder it pushes back. So a coil's reactance grows with frequency. The formula is XL equals 2 pi FL. More frequency or more inductance means more reactance. And at DC, where the frequency is 0, XL is 0. To steady DC, a coil is just a piece of wire. Let's put numbers on it. A 60 Hz source and a 0.1 Henry coil. XL equals 2 pi times 60 times 0.1. That comes out to about 37.7 ohms. Now double the frequency to 120 Hz, and the reactance doubles to about 75 ohms. Reactance follows frequency. The capacitor is the opposite. It opposes slow changes, the low frequencies. Its reactance shrinks as frequency rises. Xc equals 1 over 2 pi Fc. At DC, Xc is infinite. A capacitor completely blocks direct current, but raise the frequency and it passes current more and more easily. An example, a 60 Hz source and a 100 microfarad capacitor. Xc equals 1 over 2 pi times 60 times 100 microfarads. That's about 26.5 ohms. Halve the frequency and it doubles, exactly opposite of the coil. So does Ohm's law still work? Yes. For a single coil or capacitor, just use the reactance X in place of R. Voltage equals current times reactance. V equals I times X. So 120 volts across 40 ohms of reactance gives a current of 120 over 40, 3 amps. To recap, reactance X is frequency-dependent opposition, measured in ohms. A coil's reactance XL equals 2 pi FL rises with frequency. A capacitor's Xc equals 1 over 2 pi Fc falls with frequency. Next time, we combine resistance and reactance into one total opposition called impedance and meet the phase shift that comes with it. See you at the board.